I'll be talking with Michael tonight, and we're going to basically go over the history of mutations in the U.S. And um, Terry's been trying to get me on here for a while, and they sent me this idea for a presentation. I said, okay, yeah, sounds like the right people are doing it, so we'll go over this. So um, I'm going to kind of just go from early stuff in the U.S. and come up to about when I stepped back from breeding quail in a major role, and Michael will kind of pick up from there and go with some of the newer imports and some of the different mutations. So I'm going to be talking, since this is a presentation about mutations specifically, I'm not going to talk about varieties as much as I'm going to talk about individual mutations. So that's kind of the basics for what I'm going to do. So to go back, since we're talking about history, one of the earliest mentions of Coturnix quail is actually in the Bible. So I wanted to start there because it's relevant to what we're talking about. So there are mentions of the Bible, and I think it was during the book of Moses, and they were crossing the desert that there was like no food, and so there was manna presented all around them, and it was Coturnix quail. So the reason why I want to mention that is there's this common misconception when we refer to our quail, we refer to them as Coturnix japonica, and these guys are actually not Japanese quail. They should be considered a separate species, which would be Coturnix domestica, because Coturnix spans a huge established area in the wild, and there's multiple different species. So there is rain quail, which is a Coturnix, and they are native to the subcontinent of India. There's harlequin quail, which are present from like Central Africa into the Arabian Peninsula. You've got stubble quail, which are native to Australia. We've got japonica, so the one that is native to the islands like Japan and mainland or Oriental Asia. And then we've got the common quail, which is the most common, and they're found in Central Europe, into Western Asia, so like into Eastern Europe, and then all the way down into the Mediterranean, including Morocco and areas like Turkey and so on. So you've got this bird that the genus has been present in almost every continent, excluding the Americas and Antarctica. And so the biggest thing that causes mutations, you think about mutants. Like when anyone thinks about mutants as a general topic, you think about like nuclear radiation and tests going on and everything. But the biggest thing that actually is a contributor for mutations is hybridization. So because these quail are so small and so easily, not really domesticated, but so easily kept in captive setting, they were kept by so many civilizations all over. And as soon as global travel started, they were brought from Asia to Europe and from India to Africa and back and forth. So you had all these trades going on. So they could have been moved by Portuguese spice trade routes. They could have been moved by the Silk Road, any of these things, right? So as soon as hybridization starts, that's when you see the earliest mutations. And the most common one you usually see, the first, is white. So if you think about, just like in general, as I'm talking here, if you think about any animal, any bird that you have, any horses, goats, whatever, the first thing that you always see is whites, or a white version of something. And it's just because it's an absolutely massive gene. And so the basic definition of a mutation is kind of like when the genes are replicating and they're coming back together, in an offspring. It's just when the recombination doesn't come together perfectly, and you get an error. Sometimes there's like one little molecule that disappears, or there's a substitution, one replaces another. And this is because in hybrid blood, you have a higher likelihood of things not coming together exactly as they were in one of the parent stock. So because of that, hybridization causes mutation to occur more frequently. So with that, that's kind of my basic fundamental beginning history point for mutations of Coturnix. So if we think about that early mention, that they even mentioned them in the Bible, and that there were some present in Europe, and that we're talking about Japanese quail is usually the most common reference name, but that is specifically to the wild Coturnix quail that are found in the Orient. So ours are actually a combination of all of those, and that's why we see so many mutations, but you don't see those mutations in the wild. So starting there, I know you guys have gone over tons of genetic stuff, and probably anybody tuning in to watch this video has at least a fundamental idea about genetics. But just for the sake of what we're talking about, I'm just going to go over a few just real quick concepts. So, a locus, when you hear us talking about a locus, is the actual section, the location of DNA where a change occurs. So if you think locus, location, and then an allele is the specific version of that genetic material that's found in that location, and that's when a mutation happens. So like your original simple, what was there already is the wild type allele. And then when we have one of those errors that occur and you get one mutation that happens, that's an alternate allele that's in that same position. It's just a different form of what was there because something didn't go together just right when it was being replicated. So I'm assuming most of the people, and I'm sure we'll hear it in chat if there are questions, but I'm sure that most of the people watching are familiar with the idea of a locus and an allele on that locus. So the alleles are the forms of the gene, basically. So that being said, those are the biggest things that contribute to all the varieties that we have. Now, there are specific things that certain lines could have that same allele, but they may look a little bit different, and that is because it can get stretched to a certain degree. So when there are specific, there's a lot out there of white birds or brown birds that were in like meat lines. It's because they just heavily select for very certain um, minute things that are not individual mutations, but they're little modifiers that can contribute to a line showing differently from one to another. So hopefully that makes sense with everybody. And from there, we're going to just start with the basics of what occurred early on in the US and then bring it right to present day. So the first mutation that I want to talk about is a very simple one, and it's brown. It looks almost identical to the wild type, but it removes a little bit of black pigmentation in the plumage. So it turns, that's what we've got on the screen right now, is brown. So if you see the male on the left there, especially on the back of the neck, it's a little bit more reddish colored than the wild type. So this is a really simple mutation. It doesn't look like it's showing a lot, but it's a sex-linked mutation, and it's located on the TYRP1 locus. So if anybody wants to come back to this video later and get more information, you can come back and re-listen to these parts and look into it more if you want to. So TYRP1 is a sex-linked locus, and brown is the first mutation that we're talking about. And it does just what you're seeing on the screen here. It doesn't change them by much, but it removes a little bit of the black pigment from the like especially the back of the neck and the body, so that they're a little more red looking than they are dark. So that one's pretty straightforward. Me, I liked when I have a rosetta. This particular mutation in rosetta just enhances the color a little bit more. So it's not a huge thing. It's not easy to tell them apart, male and female at hatch, because they are so similar. But it's one of the early mutations that we had in the U.S. It was here prior to 2000. And then the second one that I'm going to talk about is roux. So roux is French for red. So the roux dilute is on the same locus, the TYRP1, and it does the same thing as brown, but it does it more extensively, and it has a heavier impact. So there's almost no black in a roux. So Terry, if you want to go to the next picture there. So these are two roux, and the variety here is called Egyptian. So if you see, looking at the plumage, the overall black is turned to a dark slate color, and the overall brown is turned down to a russet color, and you still get the same kind of like fawn pinning that goes through the plumage. So this one is, again, it's on the same locus, so it's sex-linked. This one is really handy because you can create auto-sexing hatches. The variety won't auto-sex by itself. You have to have specific mating to do it, and I'm sure it's been talked about in other videos here, but this mutation is an interesting one. And it's got kind of a muddled history in the U.S. This has probably been one of the, if not the biggest, confusions of Coturnix keeping. A lot of you probably recognize the name Robbie Richard, and he's in Louisiana. He has James Murray Farm, and he's done a lot of research in the background of the mutations in the U.S. So he has suggested that there's been up to 4 different imports into the U.S. that could have brought in the roux dilute. We know that there was some, and we don't know with certainty when these earliest ones came in because most of them weren't done legally. But before 2000, probably as early as like 1991, is when we had at least brown, rue, and some of the other common ones that I'm going to talk about here. But for sure, we know that there was origins that came from France. And during that time, there was a genetics professor in France, and his name is Francis Minvier. And I was corresponding with him a lot at the time. He did a lot of work between 2003 and 2007 on Coturnix quail genetics in an academic standpoint. And it was at that time that I was kind of like a bridge between the academic scientists in Japan and in France that were doing a lot of testing and the backyard hobbyists. So it was a cool position for me to be in where I was going back and forth, letting them know information that was in public holding and getting a better understanding of new modern genetics and understanding of quail that I could then deliver to the public also. So during that point, it was probably just before that, and Francis had been doing work on the Rue de Loup. You'll probably be able to Google if you want that you can find Lavender and Rue de Loup mutations where he was testing the effects with them. But so we know at least sometime before 2000, the first one came. There was another one that came sometime in between there. Francis also had a rusty mutation that was not sex linked, and that was in France. So it's possible that one of the forms that Robbie mentioned in the US could have been rusty. And there was one that was sometime around 2009 that was very similar, but it was really weak and it didn't thrive well. And so I always thought that might have been rusty and might not have been Rue de Loup itself. So there's a few things that you know could have originated where the oldest ones came from. Now the one that's on the screen here is Michael's bird. This looks different than mine. This is probably from a newer import. Mine, Terry, if you want to hit the next slide, were from around 1995, and you can see how much lighter mine are. Mine had a very light pastel color in them, and I liked it more because to me, they were just nice, softer color, but they also were a lot easier to sex when I was creating auto-sexing. So I was the first one in the US that realized that this was the Rue de Loup gene that had come from France, and I was the first one that did any auto-sexing hatches in the US. And it was a really big day for me to like have bred all these birds for so long and like purified the lines, and then my very first hatch day, I remember like I pulled them out of the incubator and I had a perfect 50-50 split of male and female. And I had shed a little tear that day, to be honest. I was pretty proud of the work that I did. So that being said, we're talking about the lines and the different like ways you can stretch a mutation. This could be simply a difference in line breeding, where mine I selected so heavily for this color, and some of the newer ones had different sources, so it couldn't be the exact same mutation, just stretched to different extremes. So let's see here. So then later mutations came in. I've got a little bit of notes here that I'm following. Later mutations came in that might have been from imports with the silver line that came from Perry Schofield, or possibly the German Pastel import, both of them. You had La Creme, which is a Rue de Loup lavender that could have come from Perry. And you had some cinnamon and other pastel color birds that came from the German line. The cinnamon is not the cinnamon that was in France, the incomplete albino, but it could be something else related to it. And Michael will talk about that a little bit more later. But one other variation, and if anybody's listening and wants to take a test that I never did, here's a big one if you've got your pens handy. If you wanted to get a really good line of browns and a really good line of light Rue de Loups, one thing that I never did is cross them to get heterozygous males that were split for, since it's sex-linked, you can only get a female of one or the other. However, you can get a male that is heterozygous split between brown and Rue de Loup. And I've always wondered if that male would look like a form in between this lighter Rue and the darker brown, and it may end up looking similar to like what Michael's look like now. And that could, again, contribute to a variety of different phenotypes in the way that they look. So there's a good little presentation if anybody wants to write up a small paper on Coturnix and the effects of heterozygous on the alleles on the sex-linked locus. So we'll go past roux now. So there you got brown and roux. Those were probably the earliest things that confused the crap out of people when we had them in the U.S. because being sex-linked for one, they didn't always breed the way that you expected it to, and there was this variety of tones that there were available. So it was hard to identify what you had if you didn't really know the genetics or the history behind it. And a lot of this was tricky because it's difficult to legally import birds, and it's even more difficult to export birds to specific countries. People in Australia know exactly what I'm talking about. Australia has been hard to get anything into since like the 80s. You can face fines, jail time. The USDA can come and destroy all the birds on your property. I know when Robbie had imported the birds from Perry out of Canada in the Schofield Silver collection, it ended up costing more than $500 per bird. So it's a gamble that people take, that either you pay and you do the effort the right way, or if you do it illegally, there are people that have gone to jail and faced thousands and thousands of dollars in fines just for importing the birds to have them destroyed rather. So it's one of those things that we got them here in the U.S. prior to 2000, but most of them probably didn't originate here illegally. So one way or another, we eventually had roux, brown, a couple of the other ones that I'm going to touch on here, before 2000. And at that time, there was one particular breeder who ended up getting all the mutations. She didn't really know much about genetics or how the genetics part worked, but she had so many birds that she was drop shipping them to Stromberg's and McMurray and some of the bigger hatcheries in the U.S. The problem was that they were getting shipped as eggs. So, again, the people with genetics are going to understand this a little bit better, that if you had a bird, so for example, a Rosetta or a Scarlet, and you ordered eggs from them, even if the whole pen was Scarlet, you would not get Scarlet that would hatch. You would get Egyptian, you would get Scarlet, and you would get Range. So the fact that you could order eggs that were supposed to be one thing and get 3, 4, 6 different varieties to hatch from it, it was so confusing. And then people just gave them different versions of a name. So this is when you had that really confusing time between like 1990 and 2010, that you had Dark Range, British Range, American Range, Red Range, Golden Range, and there's like all of these different things, and they were being distributed under a particular name for only one of them, and you would get 6 different varieties out of it. So that made things really hard. So it was at that point during that 10-year span that I purified all the genes to know what was making each variety, tested everything, and then we, assigned the actual legitimate names that you have now. So I know a lot of you guys who are watching know that I named quite a few varieties in the U.S. So Autumn Amber was a variety that I named. Scarlet was a variety that I named. I organized everything into all the terms that we use now. We have Tibetan, Rosetta, Pharaoh, and then we have Range, Scarlet, and Egyptian, and then you had Manchurian and Italian. So like all of these were being interchangeably used at the time. And so once I organized the varieties by the genetics, it became infinitely more possible for everybody to breed them to a standard like they are now. So that being said, I'm going to move on to the next one, and it's similar to roux. So this is the second calico that there ever was in the U.S. So the first was a male, and this was his F2, his second generation female that came from him. And they were small and they were weak. I bred quite a few, and then I ended up selling them. And so this one was probably in late 2011. The bird that's on the screen now, the original male was in really early 2011. And these were hatched out of bantam stock. So you can see how small looking it is in my hand. They actually only average 4 ounces. The males are 3.8 ounces. The females are 4.2 ounces. So again, I was the one who kind of divided up the weights of birds to have classification. So bantam average 4 ounces, standard average 8 ounces, and then XL or jumbo or whatever we want to consider it is 12 ounces plus. And that was basically, you had this 4-ounce, 4-ounce, 4-ounce staggering. So the XLs were literally 3 times the size just to be considered XL. And then there's birds that have been so much bigger than that too. I remember we weighed one of Robbie's birds at his place at 19 ounces, and that was in 2012. So I'm sure people have gotten even bigger since then. But just the classification, the grouping, the identification, and like the defining of things really set the stage for everything that we were going to do. So Calico came out of bantam stock. At the time, I was hatching 1,200 bantams a week. And in this one particular hatch, like I'd get a little bit of a bib on some, or I'd get a white one. But in this particular hatch, I actually had 2 birds that were spontaneous mutations that came out. One of them was this Calico, and then the other one I'll touch on a little bit later here. But the Calico, I never bred enough to know which locus it was on. I still think, I don't know if anyone has confirmed or not yet at this point, but I'm thinking it's probably on the yellow locus, which is the Acip. So that stands for agouti signaling protein gene. And it's an interesting one because the Acip gene has been used extensively. So if anybody knows mammalian genetics at all, the hair, like on a cat or a dog or a horse or whatever, if you blow on the hair and it makes a kind of circle, you can see bands of color. And so it's like the length of the hair has a different banding of color on it. So the Acip gene actually is what is responsible for the actual structure of the hair and where those colors land on it. So it's a real cool correlation from birds to that, because it's been studied very, very, infrequently. So again, I don't know if anybody has confirmed not since I bred these, but now they're all over the U.S. They're in Australia at least too. I don't know if they're in Europe. Maybe someone can let us know that or not. I don't know if the ones in Australia came to the U.S. What were you going to say, Michael?
I was going to say they're in Europe.
There, okay. So again, with the legality of imports, I know for a fact that people have taken some of my eggs and exported them to Europe. I don't know what eggs in total. So I don't know if the European or Australian birds originated here in the U.S. If they did, they all came from that hen on your screen right now, because that was the very first female that I had back in 2011. So we'll go past Calico there, and then the next one that is on the same locus is so here's another Calico. This is what they look like now. These are Michael's birds, and they look damn good to me. They're nice, heavy, heavy straw colored. I love the pattern in the back. And again, so if you look at stubble quail, and if you look at I want to say it was stubble and European probably had the most pattern that you see here, especially in the wings. You can see that the mutations are a lot of times derived from old, like remnant patterns from the wild stock. And I'm sure Martin and a few other people in Australia have discussed this with me on different occasions, that a lot of the patterns that occurred, mutations that occurred in Australia, were very likely the result of stubble quail hybridizing with domestics. Again, just that hybridization caused mutations that we see in Australia that we don't see other places. And so that's really likely where they came from. So again, you can see really nice bird. The hen loses the speckles on the breast, and that's one of the reasons why I also think that it's correlated to the yellow locus. And if we go on to the next one, we're going to see fawn. And so here are 2 homozygous for fawn, and the variety we call it is Manchurian, and these particular ones are redhead. So the redhead, I know somebody knows the name of it in German because it's common there. It was one that was just stretched really heavily from either pansy or from this, but there's actually 2 fawn mutations. There's a fawn 1 and a fawn 2. One causes the cocks to have a dark head, and one causes the cocks to have a silver head. And so depending on which one you like more or less, they're interchangeable. This can be bred with any of the other genes and cause split forms that are on the Acip gene too, which again, I think Calico is on as well. So these were all the Fawn was in both Fawn 1 and Fawn 2 were in the US prior to 2000 as well. And I had lines of both of them. So this is just a real straightforward one. You can see the hen lacks the speckles on the breast, just like the calico. Again, that's why I think calico is found on the yellow locus too. So there's not a whole lot I can say about them. So we'll just kind of go forward from there. It's a dominant gene. Here's one of the ones that I had. This is my hen. Again, I really stretched my lines, and I was very particular. I wanted the hens and the males to have no patterning at all in the plumage in the back. So you can see on her wings, the only pattern they have is just the shaft of the feather, primary feathers on the wings, and then the obviously the collar on the head. And the male was the same thing, but the males always have a little bit more red pigmentation. And you'll notice that with all varieties, males always have higher concentration of red pigmentation. So regardless of the mutation, that's just something that is sexual dimorphic between the two. So that's about it for those. And we'll go on to the next gene. The next locus is the, excuse me, is the EDNRB2, which is just a long name for white locus. And the white locus is absolutely huge. And when I was first talking about the mutations, why white is always the first, it's because it's the easiest thing. It's just basically the absence of pigment. And it's when there's like the simplest error where this gene is telling pigment to just not express. And since it's a huge gene, it mutates very frequently. So the picture on the screen, I chose this one just because if you see to the far left, you've got a wild type bird. And if you see to the far right, you've got a white bird. The one in between is split between them. It's heterozygous for white, but it barely shows anything. So something that simple, you just say, yeah, it's just a bird with a couple of white feathers. But when two of them breed together, you get an almost totally white bird. So on that locus, you've got... I mean, now there's tons of them, and there's new ones all the time. But around 2000, you had white, dotted white. There wasn't Panda in the U.S., but people were breeding specific lines of tuxedos that resembled Panda. But now there is Panda in other countries. There's white wing. There's all sorts of different ones. So if we want to just go through some of the pictures here of white, you can skip forward, Terry. And so there's one of my pure white ones. So dotted white is the chicks that you see that always have that little patch on the top of the head, and they usually either have a black chin, little mark around the eye, a couple of patches on top of the head. Mine, I wanted only pure white, so you can see this hen has absolutely no color whatsoever on her, and she was an albino. We didn't have albino at the time. So again, dotted white and white were so similar, but slightly different on the same allele. And Terry, if you want to go a little bit more, I think I had tuxedo. Okay. So the next gene that I'm going to talk about on here is the MC1R locus, which is the black locus, the mitochondrial receptor 1. And so the mutation that you're seeing that changes the base pattern here is dominant black or extended brown or extended black, whichever you want to call it. It's all the same thing. It's just relative. And that is a base pattern. So it's the locus that most affects the way plumage displays. And we're seeing that here with white. This bird is heterozygous for white. So on the previous bird, where it just had a couple of white patches on the chin, on this bird, you get the beautiful tuxedo pattern that everybody loves. And the white always follows a wild pattern. You don't usually think about it unless you see a photo like this. So if you think about it, the white follows a ventral line. It goes from the beak down the breast to the vent. And any extremity, which would be the toes or the ends of the wings. So this bird, you can just barely see the toes up at the top. It has pink toes. It's got white primary feathers. And you can see the pattern follows the exact wild pattern. And it's not by accident. This is because those are different feathers that in the wild bird are being manipulated by different genes to express a different color. So in this, the white is following a predetermined pattern that the genes are already telling it to. And the fact that it's got a different base pattern, this dominant base pattern, I don't want to confuse anyone too heavily right now, but the base pattern doesn't only affect that one allele, that one locus. It can actually affect genes on other loci. So what's showing here is that the fact that this bird is extended black or extended brown, and it has the other mutation for white, it's actually affecting how much white is being exhibited. So I don't want to get into that too much because that's talking about varieties and everything else. So we want to stick with mutations more. So the extended black mutation here basically makes all of the fawn coloration go away, and you've got a bird. This one in the picture probably was black, and also it may have had the sex-linked brown that we were talking about, because you can see it's kind of a little bit richer color on the back of the neck. That's my preference. That's the birds that I wanted to keep in my Tibetan lines. So if you want to skip a next one, Terry, I think is another pied. Yeah, okay. So again, here is similar things. These are both extended black. The one on the right is a roux de lutte, so that's a range. So you've got Tibetan and range. And the Tibetan, like I said, this one definitely you can see in the photo has brown. You can see that kind of reddish collar on the Tibetan on the back of the neck, and so that's that first mutation that we talked about. So again, this is prior to 2010, I want to say, in these pictures. So it was between 2000 and 2010 that I really purified all these genes, and you're seeing these are all old photos of mine, but you're seeing how really like distinctly pure all the colors are, all the varieties are, and so this one, again, was here before 2000. It was one of the ones that was distributed out, and it's really is the most important one for varieties now, because the base pattern that's underlying all the other genes is what establishes how they're going to interact with each other. So this is the most important locus that you can have, taking into consideration on what you're gonna look like with all the genes expressing. The second most important one is the Acip gene, which is sometimes considered a base gene, but it's not one that affects other loci, but it does affect that physical structure like we talked about. So in combination with the black locus, this MC1R, and the yellow locus, the Acip gene, you've got the two most fundamental combinations of mutations that set your canvas. And then every other piece of paint coloration that you splat on top of the canvas, the way that they come out in the end all are determined by that black and yellow. So I think that's about all I should yammer on about those. I'm sure we'll have a ton of questions in the chat. So Terry, if you want to skip to the next one. Here's Panda. This is, like I was mentioning before, one of the white locusts, and it kind of just looks like a panda, and that's why it's named that. So it's not the same as white. It's not the same as dotted white, and it's not just a tuxedo. It's its own thing. It's one of probably at least 20 different different alleles now that are on the white locust. And if you go to the next one too, it should be white wing. Yep. So this is white wing pied. So again, this is like as most white as it can be. So this is kind of a version of tuxedo. Again, you see it follows that ventral line, starts at the beak, down the breast to the vent, out to the extremities of the toes and the wings. Always follows that same line. You can see the head is colored because in the wild pattern, the head has a different coloration than the rest of the body. And it's just a good example of what we're talking about, but it's separate from white. So go ahead, Terry, you can go to the next one. So this one is one of my personal favorites. This is Silver. And this is one of Michael's photos. And at the time when I was doing this, Silver was a brand new mutation. So when I was talking with Francis, he was the one who was first doing the, interaction and tests about Silver. And it was we found that Silver always expressed in like a heterozygous white form. So you can see on the Silver, it follows that same ventral pattern. The primaries are white. It's got a white patch on the breast and white under the throat. But there's no white involved here. It's just that the gene works the same way. And like I've been going on about mutations here, it's like there's a predetermined way that they work, and different genes just turn things on and off. So with Silver, it eliminates almost all, it's like 95% of the red pigmentation. So you're left with just basically like a grayscale version, but it also adds in white. It's like it breaks down the ability for the color to show in certain areas. And in the homozygous form of this, it's pure white. However, it's not on the white locus, so it made it a little bit confusing. So I came up with the idea, and Francis liked the idea, so we went with this, that anything that was partial white like this would be considered pied. So most people know the term tuxedo, and it and it is regarding any of the birds that are half white, and that's with the white locus. So anything that's half white is called tuxedo. Anything that's got that pattern that's caused by silver is called pied. So this one in this picture would be silver pied. And in its true form, we called it Snow White. So that way it would be distinguished from just the regular English white. So Snow White is the pure version of silver pied. The thing that's interesting is this gene is the MITF locus, and it's actually the same locus that blue is found in chickens. So if you know how blue works with chickens, you've got the pure form is splash. And if you think about splash, it's more or less white with a little bit of blue and black leakage, right? And that is the same as what the Andalusian is in quail. So this is a different allele that's shared on the same locus as Andalusian. So Andalusian and blue and chicken are one and the same. It's the same with slate and turkeys. So if someone doesn't know this, this will blow your mind that it's literally the exact same gene. And Francis had actually done some tests, and Suzuki in Japan did some tests where they bred different species that had the same mutation or a corresponding mutation on the same locus and produced hybrids. So there have been hybrids between turkeys and Coturnix quail, between chickens and Coturnix quail. There was a whole list of them. You can find the articles on YouTube. I mean, on Google if you want to find them. But and then the resulting offspring showed the same expression. It proved that they were the exact same locus in two different species and that they were synonymous with each other. So what you're looking at here is more or less a different version of blue, as in chickens. And then Terry, if you want to get to the last one of mine here. So this little chick was one of the ones that came out of my bantams. On that very same hatch that I hatched the calico, I hatched this bird, and we called her Ash. And she matured into an absolutely amazing bird. And if you want to just slowly go through the pictures here, Terry, this was again in 2011. And man, isn't she glorious? Look at that nice dark blue silver. So it's an even deeper blue than the silver. And if you want to keep going, there's a picture of the breast somewhere here. And what was different about it, so she's on the right in this picture. If you see, the breast has the same reddish coloration that the wild type does on the left. What was different about this one is that it still showed red pigmentation in certain areas, but it had this totally dark blue. She had no white on her anywhere though, so it wasn't silver, it wasn't lavender, it wasn't Andalusian. It was a totally distinct mutation. Unfortunately, she was sterile and she never laid an egg. She's still in my freezer 10 years later. In the event that I can take some good DNA from her and we can find out what locus that mutation was on. If you want to keep going, Terry, we'll just see the last couple pictures of her. So here's a picture study. You can see on that bottom left, a nice red coloration in the breast. Yeah, she was pretty awesome. Go ahead and keep going. There's again, I just did a bunch of feather study stuff. You can see the pattern was the same. It was just took all the black and turn the slate, turn the black to slate and turn the slate to ash, and that's why we named her Ash. And keep going. And that's the last bust of her. That was at, I think, 4 weeks old maybe. And so unfortunately, we never were able to replicate the Ash. I replicated all the other ones for you guys though, and I distributed the crap out of them so everybody could enjoy them. So with that covers everything up to about 2012 in the U.S. and was at that point when Robbie was working on importing stuff with Perry Schofield. So from here, we're going to pass over to Michael, and he's going to go over a lot of the more recent imports. And hopefully I didn't confuse too many people, and I gave you a good history of everything that happened from about 1990 to about 2012 in the U.S. and where all those original mutations came from and how I kind of organized them out to the stuff that we have today.
Cool. Appreciate it, Dana.
Yeah, thank you, Dana. So yeah, around 2014, Robbie Richard imported some birds from Perry Schofield in Canada. Perry had accumulated a massive collection from the university there, and I think he did a show with you, Terry, right? Talking about all the different varieties that he had accumulated. One of the key varieties was silver, which Dana showed earlier, and a very similar mutation is called Andalusian. That was also imported with that same batch of birds. So this is an example of Andalusian. It has a lot of the same characteristics of silver, but often you get a colored patch randomly on the bird. So you can see this one has a patch of much darker plumage on the wing. Sometimes you get a little bit more color. Sometimes it's just a feather here or there that shows up somewhere on the bird. It does follow the same basic principles as silver. You get the white primary feathers. The majority of the bird is a light silver color. And similar to silver, in homozygous form, the bird is a snowy white color. It's just an off-white on the entire bird. Unfortunately, for silver and Andalusian, which is why originally Perry was told by the university that you couldn't breed them, they tend to be weak and sickly in homozygous form. So general best practice is just to breed silvers to non-silver birds if you want hardy stock. So that's a practical note for anybody raising silvers. If you do get a pure silver that's that off-white color, let us know if you're able to get it to survive more than about 6 months. Usually they don't. So we'll go on to the next one, Terry. This is even more fragile. So this is an albino. It's difficult to find pictures of full-grown albinos. So this one was just posted on Coturnix Corner or on the genetics page a few days ago. And it's a great example of the legacy from that collection. These genes are still floating around in mixed stock all over the country. This actually hatched from a celadon egg, which is an interesting side note. The celadon gene that causes that blue color on the entire egg was also imported with the Schofield silver import in 2014. So when the eggs were originally imported, there were no blue eggs. It actually showed up a little while later. And then from that random gene that was floating around in that import, Kansas City Quail Farm was actually able to pure up celadons, distribute them back to James Marie Farms, and they went all over the country. So celadons are very popular now, but they started from this import in 2014. So to my knowledge, there were a handful of other mutations in that import, but a couple of them it's unclear if they came from that or from the next import in 2015. You can go ahead to the next picture, Terry. In 2015, we had the German Pastel import. So this was an import from Germany. It consisted of about 10 birds, and all of those birds were just loaded with mutations, hence the name German Pastel. The majority of them have kind of a pastel look, but some of the individual mutations we got out of that were lavender, which you can see here. Very similar looking to silver. It shows a little more yellow. Honestly, I don't see the yellow in this picture, but they're known to express a little more yellow than silver as well. And then difference between lavender and silver is lavender is recessive. So it's not going to present the same way as silver. Any lavender that you see is going to be pure and breed true. So that's an interesting difference. My understanding is they don't have the white primaries either. So it's on a different locus. You're not. Go ahead,
Michael. Again, referring to the chickens, if anybody knows chicken genetics, it's the exact same thing with chickens, where you've got the recessive lavender in chickens that people consider self blue, they call it, because it breeds true. And then the true blue, the Andalusian, is just like you were mentioning with the silvers, where if you want to get them, you should really breed to non-blue. So it's exactly the same thing, where this is the same exact mutation that's lavender in chickens as well. So if anybody wanted to look at pictures of chickens, actually turkeys as well, same thing.
Makes sense. Yep. And so I think this is a locus you hadn't discussed, Dana. The lavender is on the MLPH locus. Do you know anything about that specifically? If not, we'll just we'll kind of move on.
Nope, just that it's a separate locus, like you said, and then it's, as far as I know, it's the only mutation that's on that locus that we know of. So it's independent of other ones, which also means, though, you could get a silver pied lavender. So that could also make things confusing. Yep. And I know that was one of the things with Perry's when it first came in, is some of them had silver and lavender, and that's when you had these totally really diluted light blue birds. So I don't know if that's a project anybody was working on, is still working on, but That's because they're on separate loci, they can be combined together.
Interesting. That makes sense. And that kind of takes us to the next mutation, which is blue. And that's an incomplete dominant mutation, also causes two tones of silver plumage. So, as if it wasn't complicated enough, understanding all the different silver mutations, there's a fourth one to throw into the mix. And this image was by Tamara Rosal. So, thank you, Tamara. Go ahead on to the next one, Terry. This one was kind of the game changer from the German Pastel collection. It was just recently identified in, I believe, Germany when that import was done. And then Robbie was very excited to find out that it was included in that import. So Falfy, in its pure form, just dramatically changes the appearance of almost every other variety. So you see that in our Calico Phi that we released this year. Pearl Phi is a very popular variety. Grau Phi, the list goes on and on and on. It seems to just provide really unique monochrome looking varieties when it's mixed with any other mutation. We don't know anything, I don't think, about the location of the gene, except that it's compatible with basically everything it's been bred to. So it's likely on its own locus. I don't know if it's been bred to all the other dilutions. So go ahead on to the next one, Terry. Dana talked about this one. It's the white wing gene. Interestingly, I've heard it referred to as white wing pied, so it kind of breaks the rules that you described, Dana. Do you think it would be better to refer to this as white wing tuxedo?
I would just call it white wing. I mean, yeah, I mean, in general, pied, which is short for piebald, in almost all animals, when there's white, it's either called piebald or another. But since we had the two different genes, it's hard to say on that because I would just call it white wing if it was me. But I don't know what, again, I haven't been in the, really like the spotlight for breeding stuff when all of these other imports came in. So I don't know what it's most commonly referred to as. Do people call it white wing specifically or white wing pied or because then
Yeah,
you
those are the
see
two
where,
most common.
yeah. But that's one of the things is like, as soon as people start releasing things, it's so fundamental having an understanding of the genes that are there and what came before them to eliminate confusion before it starts. So, I mean, this could maybe be a really good example where it's still fairly new that people could, nip that in the butt a little bit just to not get it mixed up with silver pied versions because one is a result of silver, one is a result of something on the white locus.
Interesting point. Yeah, and I did fail to mention, so this was not in the German Pastel import. This is kind of in the next wave of imports that started in 2019. So these came from Europe, and it is closely related to the dotted white gene, and it will interact with that mutation as well. So it's a different version of that allele, but it doesn't act independently. So if you have one dotted white allele and one white wing allele, you're going to get a different looking bird that's kind of in between the two. However, if you breed white wing to white wing, this is as white as it gets. So it shows this pattern, and they do breed true. So it's an interesting variant of white mutation.
This is probably very
I
similar
think,
to pinto and guinea fowl. Because if you know guinea fowl at all, that's essentially the same thing. And actually, in Australia, anyone who's watching from Australia, your guinea fowl there, you'll know that you can never get a white guinea fowl, and yours will look like this. The guinea fowl in Australia are white wing as well, same mutation.
very interesting. So this one is a little bit of a mystery. It's been sold as cinnamon in Europe for several years, and it was recently imported here. It does follow the same inheritance, so it's on the Z chromosome. It's sex-linked recessive, and this is one of my birds. The way I got a hold of them was through a carrier. So I identified a carrier male, 50% of his offspring hatched looking like this hen, and then I was able to breed those offspring back to the carrier male to finally get some cinnamon males. So that's a that's an interesting variety. They hatch with red eyes, similar to albino. They do seem to be a little more robust. They are still fragile as chicks, but they're not as fragile as albino. Um, they grow out of it within a few weeks. I think this bird's about 5 weeks old, and they actually turn into a really hardy bird. So there's one more mutation on that albino locus that would cause the red eyes, called ghost. To my knowledge, that's not in the U.S. That's out there somewhere though. Go ahead to the next one, Terry. This one is very common in Australia. Um, it was imported in 2019 in some mixed stock. There's still some hobbyists who are uh, cleaning this up, trying to determine exactly what's going on there. Sandy in Australia is known to be sex-linked dominant, so it's the only sex-linked dominant mutation that I'm aware of. And there's some other mutations that also came from that import that are very similar looking. It's been referred to as Oz dilute or unknown diluter. So any hobbyists who have gotten mixed stock that have birds that look like this, if you want an interesting project to take apart, crossing these types of birds to Pharaoh and seeing if you get that type of inheritance, or if it splits into, for example, Rue with Phi, which looks very similar. You can identify those as older genes that have been in the US for a while. But if you see that sex-linked dominant inheritance, then you're working with Sandy. It'd be very interesting to pair those up and use those in a commercial setting here in the US, as well as experimenting with the unknown diluter if that's what you have a hold of. So I don't know the relation between that and other genes. I suspect it's similar to lavender, but there's a lot of work to be done on these. So there's one more major import, or one more major gene that was imported to the US. So if you want to go to the next slide, Terry, we'll talk about that one. This is sparkly, and it's another gene on the MC1R locus. So this is going to act very similar to extended brown. It's incomplete dominant. This is a pure bird. But Terry, if you go to the next slide, you can see a heterozygous bird or a heterozygous male and female right next to each other. So completely different pattern. The back looks almost wild type on these. The pinning or striation is a little bit narrower than a wild type bird, and slightly darker on the entire bird. The males in particular have this diamond-like pattern on the breast, so really interesting, the white that comes through, and then the copper is darker. The females have the speckling that just continues in much more dramatic form all the way down the breast of the bird. This is an interesting pattern, like Dana was explaining with the other MC1R genes. It just sort of lays the foundation for the plumage, and it can interact with lots of other things. So the next slide shows this gene interacting with some different colors. So there's a pearl Phi version on the front there, an Italian version just to the top right of that, a red version to the top left. So just a really interesting variety to play with. A really interesting gene to play with that produces all kinds of varieties.
Michael, can I ask, have you ever gotten a calico that's heterozygous for sparkly? I'd be interested to know, since they're basically two different mutations that are on likely different locus, and they are doing opposite things. Like one is removing the speckles and one is making more. Have you ever bred a calico that was heterozygous for sparkly?
No, I haven't. That'd be a really interesting cross.
Yeah, I wonder if anybody else has done it. So again, these are like pieces of candy for me seeing them, and because all these came in after I got out of